Today's topic is waves. A wave is an oscillation that travels from one place to another. So the word oscillation just means something that repeats in motion regularly. So for example, if you had an object on the water as shown in the picture and you tap it, it would send ripples throughout the water. So these ripples is just water oscillating, and this oscillation that travels is called a wave. And so waves can be described in this motion as well. Waves carry information that spread through connections. So, for example, radio waves carry television signals, microwaves carry cell phone conversations, or any media updates. Those are sent through microwaves. There are two types of waves. We have mechanical, which you need a medium to travel through, like sound and water, and electromagnetic waves. They don't need a medium to travel through, and as a result, they're faster. So, light and radio. And we have two types of shapes for waves, either longitudinal or transverse. Longitudinal are also called compression waves, and they move parallel to wave motion. And the way I remember the motion of longitudinal is kind of related to geography. Longitudinal is from left to right. It's parallel. And so, for example, this person pulling on a large spring, that spring is going to move left to right, not up and down, just left to right. Same thing with sound waves. And so a longitudinal wave has compressions, areas that are compact, as shown in the picture here. And it also has refractions, where it's not as dense. And so one wavelength in this type of longitudinal wave is one compression and one refraction. So if you see here, they start off right in the half of the compression and they end on the half of the compression with one refraction in the middle. I could have also, let me erase this. I could have also had my wavelength start here and here. It's all the same thing. I have one compression and one refraction. As long as I have that, we have that a wavelength. Now a transverse wave moves perpendicular to the direction of that the wave moves. So in other words, it's moving up and down. So for example, this girl that's pulling on this string is causing the wave to move up and down. So at some point it'll go like it's going up, and then it'll go down, up, down, up, down. And so in order to remember the movement of transverse, remember trans means different or opposite. So it's moving from up and down, perpendicular. So in order to know more about the transverse wave, we need to be able to label them correctly when we're talking about a transverse wave. So for example, a crest is the highest point, as shown here, and the trough is the lowest point on a wave. Amplitude, it's the distance from the crest to the middle. So it could be here, or it could also be from trough to the middle, from here to here. Okay, it's only like half the distance. A wavelength, and this is very important, is the distance between one point of the wave and the exact same point on the next wave. So for example, on this picture, we have this point of the wave, and this point of the wave is the same point from the wave. Now, let's say I draw another wave here, and you should draw this on your notes as well. Let's say we have the same wave. I can also label it a different way. I could say the wavelength starts here at this beginning of the wave, and it's going to end at the same point on the next wave. So I'm going to end it right here. So that can also be a wavelength, and that makes sense. You see, let me color code it. We have this first half right here, and then we also have the next half right here. So that is all one wavelength. So we use the Greek letter lambda to represent wavelength. So a lambda looks like an upside down Y. So when we talk about frequency, we're talking about how many times we see that wave go through. So frequency is the number of cycles per second, and we give the unit hertz to that. So the frequency of one cycle per 1 second is 1 hertz. So sometimes, for example, this the blue wave in the background has 1, 2, 3 points. So that's that frequency. Let's say we had a lower frequency, that would have waves that are wavelengths that are way wider. So this has lower frequency. A period is the length of time for one cycle. So for example, from this movement from the left to the right and back to the left, that's one cycle. So that's one period for that. Frequency and period are inversely related. And so period is represented by a capital T, and it's in seconds, equals 1 over the frequency. And if we were trying to figure out frequency, it's just 1 over period. The speed of a wave determines how fast it can transmit that oscillation back and forth. So wave speeds range from have a wide range. For example, water waves are slow, while sound waves are a bit faster, and finally light waves are the fastest of them all. Speed is frequency times wavelength. So speed is represented by v, and it's kind of like slanted a little bit, equals f, which is your frequency, times the wavelength in meters. So for example, a wavelength for a wave is 0.5 meters. Okay, so the wavelength is represented by lambda. And its frequency is 40 hertz. So f is 40 hertz. What is the speed of the wave? So remember, speed, let me write it, equals frequency times wavelengths, and so that's what we have here. Frequency is 40 hertz, wavelength is 0.5 meters. 40 times 0.5 is 20 meters per second. That is the speed of the wave.